Hello, hello. We are doing 7.2 now, which is points, lines, and planes. So lots of definitions here. Some vocab: point, line, plane, collinear points, coplanar, space, segment, ray, opposite rays, postulate, axiom, and intersection. So lots of different things that you probably have heard of before. Looking at this problem, it says make the figure you have to write with a pencil and a piece of paper. Okay. I just want you to visualize it because I can't do that and show it to you on this video. So, is it possible to make this figure with a straight arrow and a solid board? Explain. Well, if the board is completely flat and the arrow is completely straight, then no, because you can't have that going through twice, because it would have to bend at some point to go back up through the board again. So, no, it's not possible. We're going to talk about what this board would represent in terms of geometry and what the arrow would represent mathematically. Geometry is a mathematical system built on accepted facts, basic terms, and definitions. The basic ideas of geometry are, the very basic things we're using are words such as point, line, and plane. Okay, these are all undefined terms. And undefined terms are basic ideas that you can use to build definitions of other figures in geometry. Although you cannot define undefined terms, it is important to have a general description of their meanings. So a point, so these are three undefined terms that we pretty much build geometry off of. A point indicates a location and has no size. So no matter if I make a point this big, oops, come on, this big, oops, that's not a point, this big, or if I make it this big, it still has no size, okay? It is just representing a location. You can represent a point by a dot and a capital letter, such as A. So, like this. That says point A. A line is represented by a straight path that extends in two opposite directions without end and has no thickness. So again, it doesn't matter how thick you draw it, it's just representing a path, okay? A line contains infinitely many points, and you can name a line by using any 2 points that are on that line. So in this case, we can say this is line AB, because point A is on that line and so is point B. Or BA, it doesn't matter the order, it's commutative. Or if it is named, it's got a lowercase letter, we can just call it line L. And then lastly, a plane represents a flat surface. Okay, it extends without end and has no thickness. Okay, so think of it as like a piece of paper that is extending forever and is no thickness. Okay, and a plane contains infinitely many lines, which means there's also infinitely many points. You can name a plane by a capital letter, such as P. So if you have this P in the corner right here, we can say it's plane P. Or you can use at least 3 points that lie on the plane. So in this case, A, B, and C all lie on this plane. So we can say this is plane ABC. Okay, those 3 points can't lie on the same line though. So notice that these 3 points form a triangle. In order to name a plane, you have to pick 3 points that will form a triangle. So I can't pick points like if I had points here, here, and here, and they don't form a triangle, they just form a line. I can't pick those. Okay, the points have to form some space, some area. Okay, points that lie on the same line are collinear points, and points and lines that lie on the same plane are coplanar. So, for example, A and B in this line, those are collinear because they lie on the same line. A, B, and C here are coplanar because they all lie on the same plane. Alright. Okay, so look at problem 1 here, just naming points, lines, and planes. What are 2 other ways to name line QT? So QT is this vertical line right here. Oh, that's pretty bad. Right here. So basically you can use any 2 points on that line. You could also just call it line M. So we could say this is line M. We could also just use this N point here. We could say it's NQ because both of those points are on the line. We could also say it's NT Or you could reverse those and say it's Tn or Qn, or you could say TQ. Okay, what are two different ways to name plane P? So plane P is this yellow plane here. Remember, this actually goes on forever. It's just like your lines have arrows that go on forever. This plane is going on forever in all directions. You just can't draw it forever because it's impossible to do. So to name a plane, we have to pick at least 3 points that are on that plane. So we could say P, and they have to all form a triangle. So I could do R, V, and S. See, those all three form a triangle. So I could say plane R, V, S. I could also say plane, I could do V, Q, S. S. I could switch up those orders. Order doesn't matter. But if I say plane RQS, that doesn't work because that's just giving us this line here. Granted, all three of those points are on the plane. There could be another plane that goes through all those points because they all fall on the same line. So I could have like a vertical plane coming up like this that still goes through all three of those points. Okay, so they all have to, remember, they all have to form a triangle. They can't lie on the same line to name a plane. So this one does not work. Alright, and then, last one here, sorry. What are the names of 3 collinear points and 4 coplanar points? So the collinear points, we could say R, Q, and S. We could also say T, Q, N. Okay, because they all fall on the same line. Coplanar, 4 coplanar points, just points that fall on the same plane. So we could say V, R, Q, and S, because they all fall on plane P. In fact, you can also say points T, Q, N, and S, because they would fall on this vertical plane that goes through these 2 lines here. So it looks kind of like this. Okay, even though there's not a plane drawn there, you could fit a plane that hits all 4 of those points. So those are also coplanar. Okay, so go ahead and try this, and I will do it as well. You can pause this in 3, 2, 1, pause. Okay, so I think we actually just did this, except for D. D is different. It says which 2 points are not coplanar with points R, S, and V. So T and N are not coplanar because they don't fall on plane P here. Q does, so you can't say Q because Q is on plane P as well. Alright, next. Okay, the term point, line, and plane are not defined because their definitions would require terms that also need defining. So those are, again, are very basic or undefined terms. You can, however, use undefined terms to define other terms. So a geometric figure is a set of points. Space is the set of all points in 3 dimensions. Similarly, the definitions for segment and ray are based on points and lines. So segment here, it says a segment is a part of a line that consists of 2 endpoints and all the points in between them. You can name a segment by its 2 endpoints, such as AB. Notice there's no arrows on top. It's read as segment AB, or you can say BA. A ray has an endpoint, and then it extends forever in one direction. So it's part of a line. It's kind of like a half line. So it has an endpoint, and then it extends in one direction forever. You can name a ray by its endpoint and the other point on the ray, such as ray AB. And notice the arrow is in the direction that it's extending. So the arrow is pointing to the B, not to the A, because A is where it starts. Opposite rays are 2 rays that share the same endpoint and form a line. So this actually is one line here, but this line you can split up into 2 different rays. So we could say this is CA going this way, and then also CB going that way. So those are called opposite rays. Okay. Next. Okay, what are the names of the segments in the figure at the right? Well, we have a couple different segments we could do. We could do DE. It's a segment, so we just put the line on top. We could do DF. Come on. Hello. DF. We could also do EF. And then if you reverse the order of those, it actually just represents the same ray or same segment, so we don't need to list FE, FD, and ED. Okay, and then the names of the rays, so we could say start at D and go this way, so that would be D. You can actually use E or F, it doesn't matter. So I'm going to say DE with the arrow pointing toward the E. You could say EF, which does not include that point D, extending that way. You could say, we can't really start at F because we don't know any points after F, so we could go this way now and say ED. This time the arrow is pointing to D. Or we could say, going from this way to here, whoops, we could say FD or FE, doesn't matter, because it hits both of them eventually. Okay, so those are the 4 rays you could do. And if we knew more points, we could say even more, but we don't. So, which of the rays in part B are opposite rays? So opposite rays, remember, they have the same endpoint. So these are the only ones that have the same endpoint. So what does that even say? ED and EF are opposite rays because they both start at E, but they extend in opposite directions. Okay. Okay, a postulate or axiom is an accepted statement of fact. Postulates, like undefined terms, are basic building blocks of the logical system in geometry. Okay, so you've used some of the following geometric postulates in algebra. For example, you use postulate 1 when you graph the equation y equals 2x plus 8. You graph 2 points and drew a line through the 2 points. So postulate 1 says through any 2 points there is exactly one line. So if we have points A and B, there's only one line that goes through both of those points. Okay, when you have 2 or more figures in geometry, their intersection is the set of points that they have in common. So for example, when these 2 lines intersect, they have one point in common, and that's that point 3, 2 here. We graphed these when we were doing algebra a couple chapters ago, and found the intersection, and that was our solution. Okay, that's the point where the two equations have in common. So that's your solution. It also works with planes. But it's actually the set of all points that they have in common. Okay, so if it's 2 lines, if 2 lines intersect, 2 distinct lines, that means 2 different lines, then they intersect at exactly one point. So there's only one point where 2 lines can intersect if they're different lines. Meaning they're not the same line, because if they're the same line, then there's infinitely many intersections. So when it says distinct, that means 2 different lines. Okay, and then there's a similar postulate about planes. So if you have 2 planes that are intersecting, they form exactly one line. Okay, so notice these 2 planes here. Their intersection is this line right here, and that's going to go on forever because your planes extend forever. Okay, and that line has infinitely many points. Okay, so when 2 planes intersect, they form one line. When 2 lines intersect, they form one point. Okay, when you know 2 points that 2 planes have in common, postulate 1 and 3, tell you that the line through those points is the intersection of the planes. Okay, so looking at this, it says each surface of the box represents part of a plane. What is the intersection of plane ADC and BFG? So ADC is the top plane up here. So where does the top plane intersect with BFG, which is BFG? That's this plane right here. So what do these 2 planes have in common? Well, that's going to be this, struggling, BC right here. So the intersection is just, we're going to say, is BC. And that's actually just a segment because this is a box, so it doesn't go on forever. If it did go on forever, we would just say it's the line BC. Okay, next. Okay, what are the names of 2 planes that intersect in line BF? So BF is here. The 2 planes that intersect there are going to be this one and this one. So you can name those a couple different ways. You could say plane AEF and plane BFG. But remember, you only need 3 points. So you can choose any 3 points on that plane. So there's different ways to name that. Why do you only need to find 2 common points in an intersection of 2 planes? Well, because you only need 2 points to name a line. And the intersection of 2 planes is always going to be a line. So that's why you only need two overlapping points, B and F. Alright, 2 more. When you name a plane from a figure like the box in problem 3, list the corner points in consecutive order, meaning you have to go in order. For example, plane ADCB and plane ABCD are also names for the plane on the top of the box. Excuse me. And plane ACBD is not. So ACBD, you don't want to go out of order. So you don't want to say ACBD. Okay, you want to go around in the circle. So ADCB, or you could say ABCD. Or you can start anywhere, but just don't, skip over points and then come back to them. You could also just say DAB. Okay, but you don't want to say DBC, because then I guess you could say that actually, but you don't want to say DBCA. You want to go in consecutive order. Okay, photographers use three-legged tripods to make sure the camera is steady. The feet of the tripod all touch the floor at the same time. You can think of the feet as points and the floor as a plane. As long as the feet do not lie in one line, they will lie on exactly one plane. Because if all 3 of your legs of the tripod are just in one line, it's going to tip over, so it's not steady. So it's got to have that triangular base to form a plane and remain steady. So that brings us to postulate 4, which says through any 3 non-collinear points, meaning they don't fall on the same line, there is exactly one plane. So points Q, R, and S are non-collinear. They don't fall on one line. You'd have to draw 2 different lines to hit all of those. Plane P is the only plane that contains all 3 of them. Okay, and then looking at this, what plane contains points N, P, and Q? And shade the plane, so N, P, Q is here, so that's going to be that bottom plane there. So, you could just say plane N, P, Q. But it is that bottom plane. What plane contains J, M, and Q? Well, it's going to be plane J, M, Q. And that's going to be, which plane? J, M, and Q. So J, M, and Q. So actually, J, M, and Q, where's Q? So that's actually not even a plane that's illustrated in this diagram, because J and M, they don't connect with Q in this box, but if you connected them like this, they would form that triangle. So it's actually the diagonal plane that would cut through the box diagonally. So that plane is going to be the diagonal plane like this. So let me redraw that. So if you connected JM to PQ, that would go through the middle of the box, but that is still a plane. It's just not drawn in your figure, okay? But that's what it would look like. It would be cutting that box in half diagonally. Okay, so there is still a plane there, because there's only 3 points. You can draw a plane through any 3 points. Just maybe it's not illustrated in the figure, so you have to draw it. Okay, and that is all I have for today, for 7-2. So hopefully you have a good understanding of what planes are, and points and lines. And I'll catch y'all on the next one. Adios.